All right, in this part of the video, we're going to talk about tangent and cotangent graphs. So when we look at tangent and cotangent graphs, we are going to be talking about the shapes that those make and some key features about them. All right, so to figure out our coordinates for these, again, we're going to let x be our angle axis, the theta, and then we're going to let the y-coordinates be the tangent of those. So when we do this, I'm just gonna put these in on my calculator to get decimals. So tangent of 0 is 0. Tangent of pi over 4, if you're in degree mode, that's 45 degrees, is 1. At pi over 2, the tangent at pi over 2, which is 90 degrees, is undefined. The calculator says error. At 3 pi over 4, which is 135 degrees, we get -1. At pi, we'll get 0. 5 pi over 4, let's see, that's 225 degrees. We get 1. At 3 pi over 2, that's going to be 270 degrees. Calculator says error, so undefined. That's going to be the location where our cosines will be equal to 0, because remember, tangent is sine over cosine. Let me just write what I'm talking about here. And if cosine is equal to 0, that's when the tangent will be undefined. Let's see, 7 pi over 4, we're going to get -1, and then at 2 pi, we're going to have 0. All right, what does this look like when I graph it? So I have the origin. I have at pi over 4, 1. Pi over 2, undefined. So it looks like it kind of does this. Let's see, 3 pi over 4, -1. Pi, we get 0. 5 pi over 4, 1. Oops, 3 pi over 2 is undefined. I'm getting ahead of myself here. And then 7 pi over 4, 2 pi. And then, of course, we hopefully notice there's always a pattern to these. So we're probably going to have another one that continues over here. And then this would continue on up. All right, so when we look at these, notice that we have several asymptotes. So when we talk about the domain, the asymptotes are occurring at intervals of, so we have pi over 2, and then every integer pi after that. So let me write that x such that x cannot be pi over 2 plus pi n. So it's always the pi over 2's adding pi to each one that we can't have a value of it. Range, however, notice the arrows on both ends. So the range is unrestricted. Haven't seen that one before. Let's see, for the period, we'll call one complete motion of this. We'll call this one complete motion right here. So we're going from -pi over 2 to +pi over 2. So pi over 2 minus -pi over 2, double negative. So we get 2 pi over 2, which is pi. So we have a period of pi. And for the amplitude, well, that's terrible. For the amplitude, there is none because once again, we have arrows going off to infinities, so no amplitude. Okay? All right, looking at this, we're going to compare this to the cotangent. So to figure out my table for cotangent, I'm going to look first to see where I have tangents equal to 0. Those will be undefined in the cotangent. Where our things were undefined become zeros, because you're taking something over 0 and now making it 0 over something, so it's 0. Ones become ones, and -1s become -1s. So this is what we've got. So let's graph it. So 0, we have an asymptote. I'm going to get all my asymptotes. We have them at pi and 2 pi. Noticing the intervals here, we'll talk about this right now. Our domain is x values such that x cannot equal n pi. So multiples of pi. So we'd have another one over here and at negative 2 pi. All right, so the graph. At pi over 4, we have 1. Pi over 2, 0. 3 pi over 4, negative 1. So it's going to kind of come downward, a decreasing function. 5 pi over 4, 1. 3 pi over 2, 0. 7 pi over 4, negative 1. And that's what we've got. And it would keep going on this cycle on the other side. And just keep going. So when we talk about the range for this, we also have an unrestricted range because the arrow's on both ends. For the period, let's see, we go from 0 to pi, so pi minus 0 is pi. And for our amplitude, there is none because we go off to infinities. So now, how do the graphs of tangent and cotangent compare? So when we look at these, they have continuous ranges. I guess really that's not, I shouldn't say it as continuous range. That's not the best way to say that because continuous would mean that there are no gaps or asymptotes. So let's write that again, or instead as unrestricted range. Okay, that's supposed to be a negative. Let's see, we have intervals of asymptotes. We also have periods of pi. What are some key differences? Cotangent has asymptotes at the zeros of tangent. So let me show you what I mean by that. When we look at the graph here, when we have a 0 on tangent, we have an asymptote on cotangent. So here, tangent, we have pi. It's an asymptote on cotangent. Okay. Also, tangent is increasing while cotangent is decreasing. Okay. So if we look at tangent graphs are increasing from left to right. Cotangent is decreasing from left to right. All right, and we're going to talk a lot more about these different properties of these functions, so stay tuned to class and we'll talk about all of this.